Hey everyone! Today we're going to discuss a C++ hack, or at least I consider it a hack because it was not super intuitive figuring out how to do this. So what is this, you might ask? And that is the goal that we have is to destroy singletons when a program ends. Now you might not know what a singleton is. If you don't, stay tuned. And we are very grateful to have you here. So if you would consider subscribing, that would be much appreciated. It does help out the channel and helps get this information out to a larger audience. And if you like this specific video, also please hit that like button. It lets me know what content everyone is most interested in. All right. Oh, yes. And also, you don't need to rewrite all of this code that you're about to see. The Simplex TK, which is a toolkit I wrote, and you can find it at github.com/sudo-cpp. There we go. Already has all this implemented, so you can just pull that down. There's a quick start repository, and you can type in the name of your program, and you get all of the tools, which are more than just this. There's an internal keyword, which is similar to C#'s. Java, I guess, has something similar as well. I don't remember what it's called, though. It's definitely not as simple as the word eternal, internal, there we go. And signals and slots and all sorts of other fun things come along with the toolkit. All right, so enough of all the marketing stuff. What is a singleton? Well, a singleton is a single instance of an object that you have that runs through the duration of the entire program. And I ran into a specific instance where I wanted to write something on top of an ncurse library. Basically is like a wrapper around ncurses. When you would implement your program, it would automatically set the terminal up. It would turn on all the colors and get mouse support and everything that you could want. And then when the program ends, you want everything to go back to the way it was before you originally ran the program. Otherwise, your terminal is all messed up. And singletons don't actually call their destructors at the end of a program. And you want proof of this? I have a singleton here. I get its instance. I run count 3 times. And what do I get? Created, count 1, 2, and 3, but there's no destructor that's ever called. So, this video will obviously show you how to do that. Let's look first at this my singleton class that I have here. You can see that it is a singleton, so indeed there is a private. I can add that in here. By default it's private because it's a class, but there's a private instance that we have. The constructor is also private, so you cannot create this outside of the class itself. Cool thing with singletons. And then within the instance, we have a variable that we're just going to work off of. Now, publicly available, there is a destructor. There is the ability to get the instance. And I'm bringing it back as a reference because I enjoy working with references. And then we also have our count that's done here. Now, how is that implemented? Well, we have to save a spot for our pointer. So what we do is we declare it as a null pointer right off the bat. And then after that, you can see in the constructor, when it's constructed, it sets our count to 0 and it displays created on the screen. When you call getInstance, it checks to see if the instance is still null pointer, and if it is, it'll create a new one, and then it will return it as a reference. That's why the little asterisk is there. When we call count, we're able to increment our current call by 1, and then we say how many times it's been called. And then there is a destructor, and it should say destroyed. That's not being called yet. So let's find a way to do it. And that way is pretty simple. There's some more code you haven't seen yet. But if we add to include a singleton, and then we publicly inherit from that, And on our constructor, we obviously need to support construction of what we're inheriting from. So we're just going to add singleton here. There we go. And now if we run it, we can see that the destructor is called when the program ends. Now, if you think about that for a second, you might be wondering, well, how do we actually do that? And the magic is actually in the singleton manager. So the singleton manager quite simply has a vector of singleton pointers and the ability to add a singleton to that vector and a destructor. And if you'll notice under the CPP file here, the singleton manager is created the minute the program starts running. So it will be created on the stack. And that means when the program is done running, the singleton manager will go out of scope. Its destructor will be called. So that's the nifty thing we're doing here is in the destructor, we're looping through all of the singletons that have been created. We're going in reverse order so that the newest created one is the one that is destroyed first. But then we go through and we destroy them. So that is how we're forcing the destructors to be called. And the rest of it is basically just a framework to make all that magic happen. So there's obviously the register instance. This, as you saw, is a static function or static method. So when it is called, this also has to be static. Anyway, though, we're just saving that pointer to that instance. And you'll notice that we didn't pass the word this or anything. And we didn't have to register. All we had to do was include this class and it did all the other work for us. So how does this work? Well, we can see there's a public constructor, a virtual destructor. Yes. I'm not sure if I mentioned this, but whenever you destroy something and it uses polymorphism, remember to use the virtual destructor, otherwise bad things happen. And there's also an explicit of how to convert this to a singleton pointer, which is used shortly. Now, when we look at the singleton itself, the minute it's created, it passes this, which is a pointer to itself, to register instance, which we saw saves it to the vector. And we also can see how it explicitly converts itself just using a simple C-style cast here. And then there's a destructor, which does nothing. There's nothing special we need to do. Just needs to be there. So I guess looping through and actually seeing how this works. When we call get instance, what that does is it checks to see if our instance even exists yet. If it doesn't, it creates a new one. If it does nothing. Then we return it. Great. So we have our instance of singleton. And it will have said created because we just created it. Then we count 3 times. Now, for the destructor part to work, we'll remember that while it was being created, it called the constructor for singleton. And the constructor for singleton said register it in our vector. And it's saved into that vector. So that is how all of that happened. Now, when this program ends, singleton manager's destructor will be called, which is this. It'll go through each one and tell it to delete the singleton. And now remember, from its point of view, these singletons are not my singleton. They're still the low-level singletons. And that's part of why virtual destructors are so important. When the compiler goes through and the program says, I want to destroy this singleton, since it is virtual, it'll say, oh, I can't actually start here. I need to pull and call the destructor of the actual class itself. And that's how it does it. So hopefully that makes sense. It might seem a little bit of convolution because of just the way it works, but you can see It does work, and if you don't want to remember all of those internals and how it does all of that stuff, just remember that you can download the toolkit, which has a bunch of additional extra tools. So I hope you found this video enjoyable and educational, and if you enjoy puzzles, yeah, this is definitely like a puzzle. So we look forward to seeing you in the next one, and please do consider doing all the fun YouTube stuff to make the channel popular enough that your friends, family, and maybe even your enemies can find it. All right, well, we'll see you later.